Welcome to the start of Unit 4 in ACT Prep. We're about halfway home with our topics. Gives us a little more time to be working on test-taking strategies and actually taking some of those. But for today, we're going to be taking a look at slope, distance, and midpoint as we get into some of our geometry topics. Slope, one of the biggest issues we have with people is mixing up the formula. People remember that it's y's and x's, but sometimes they think to add, sometimes they do x over y. So the big thing to remember in going through this part is it's the change, or the change in x over the change in y, or rise over run. Rise is your y-axis, it goes up and down. Run is your x-axis, it's left and right. So I'm going to actually jump down to example 2 because we're going to run into a problem that a lot of people do on these. I always, when I'm doing my slope formula, put in my fraction bar and my minuses right away, and here's why. When it comes time to actually plug into the formula, okay, and the order that I take my y's the first time doesn't matter, but I'm going to be a stickler here and do the second and then the first. So -1 and -1. And then with my x's, I have -3 and +2. And you'll see why putting my minuses in came in handy. Up in the numerator, I have minus and negative. I might have just put -1 minus 1 if I didn't think about this, and that's one of the dilemmas we run into. When you subtract a negative, of course, that becomes plus a positive. And -1 plus 1 is 0. -3 minus 2, I owed my friend $3, I borrowed 2 more, now I owe 5, and then comes the big question. 0 divided by 5, is that undefined or is it 0? Real easy way to remember. 0 divided by something, if you punch it on your calculator, comes up 0. If you have a number divided by 0 and you try to put it in your calculator, you get an undefined message. And the other easy way to remember is I can't divide something into 0 parts. So that's the easiest way to take a peek at that. But here's more like the application type problem you'd see on a standardized test. To check the slope of a ramp, a building inspector places an overlay of the standard XY coordinate plane on the construction blueprint. A lot of you at this point have said, oh my god, this is going to be too hard, screw it, and have skipped it, but stick with me. So the x-axis aligns with the horizontal on the blueprint. The line segment representing the side view of the ramp goes through the points 1, -3, and 12, 2. What is the slope of the ramp? In a very long, overworded way, they're saying, take those 2 points and find me the slope. Okay. Here's my bar. My y1 and my y2, so 2 minus -3, and my x1 and my x2, 12 minus 1. We just got done saying when you minus a negative, that's going to make this become plus. It should be 5 over 11, and I get the right answer. Now, just to give a couple of heads up on things. Some of you go, well, if I mess up the formula, I'm still not going to get this right. Or if I did, 2 minus 3, there's -1 over 11. And, what's some other things I could do? Here's another option. If you were trying to do something quick with a sketch, and it doesn't even have to be accurate, you don't have to make all the little lines. You could do 1, -3, 12, 2, and go, okay, approximately here's my line. Now, why would I do that? Well, look at this line. Has it got a positive or a negative slope? It goes up to the right, which means it has a positive slope. Well, if that's the case, every answer over here that doesn't have a positive slope isn't the answer. And I also can look at my line and say, you know what? It looks like it goes up less than it goes over. It has less rise than run. Less rise than run. This has more run. You can even do it without even making choices, okay? Without even using the formula. So again, those of you that like to think of ways to get out of stuff or think of ways to get outside the box, I'm giving you permission to do it. You're not even having to get tricky, so I'm just saying. Let's say if you're given a line and you're trying to find the slope, okay? That's going to be found as my m value, the value here in front of x. The b, or the number on the end hanging out by itself, is the y-intercept. Now be careful. What's the slope of the line? People look at, well, it's 2. Get into slope-intercept form first. And notice one other thing I'm going to do here. Notice it's y equals mx plus b. The x term is first. Write your x term first. I cannot combine these. This is not 6 minus 2 is 4. This has x, this doesn't. Now that I have it in slope-intercept form, Now I can tell you what the slope is. It's the number in front of x. And that's the way it'll always work on these. Same thing. What's the slope of the line? I need to get the y by itself. I want that 3x out of there. I want that plus 4 out of there. And I can do it multiple steps at a time. If you like doing them single steps, that's okay too. Again, x, no x, those have to stay separate. Divide each term by -2. So sometimes it can take a couple of steps. And if it doesn't go in evenly, leave it as a fraction. No decimals here. And again, the number in front of m is my slope. So again, whoops, I just noticed I kind of took off there on you. So again, make sure that you're taking your time, and it's details, signs, forgetting to move something that get you on these. Slow and steady wins the race. Flipping over. Okay, next up we've got slopes of parallel and perpendicular lines. Parallel lines have the same slope, and perpendicular lines, now this is a little trickier when we go to talk about this. Perpendicular lines are what are called negative reciprocals, which basically means you're going to flip the fraction, and once you flip the fraction, then you're going to switch the sign. So for instance, what's the slope of the line that's parallel? It's already in slope-intercept form. Parallel means the same slope. So we just steal it. Okay, what's the slope of the line perpendicular? Now here's one thing I'll start to mention. I always like my slopes if they're whole numbers to become fractions. Why is that? Because I look at my original problem here, and my slope is -2/1. But I want the perpendicular one, which means to get my actual fraction for this, I flip this over, which makes it 1/2. And since it was negative, it now becomes positive, and that's my answer. So again, lots of things to think about here as you're working through problems like this. If they're not in slope-intercept form, again, you have to get them there first. Divide by the -4. Once it's in that y equals form, then you can answer the questions. Parallel, same slope. I just steal the number that's in front of x and go about my business. Okay? Just continue to do that. Always have it in y equals before you try to find out anything with slope. Okay, distance. Now, if it's on a number line, we're just going to find the absolute value. And again, absolute value just means it's going to come out always positive. When you talk about distance, you're driving somewhere. When you drive there, if you go 10 miles and you drive home, does the odometer go back 10? That'd be kind of cool, but no, it keeps going forward, and that's how distance works. What's the distance between -4 and 12 on a number line? Okay, I could do -4 minus 12, which would be -16. But again, this is distance. It's absolute value. So I get a positive answer out. Could I, even though it would take a little more time, draw a -4 and then just go -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then just count all of the lines in between and get 16. Yes! This is nicer, but sometimes when you have the pressure of a standardized test, you're not going to remember every formula. So if that's something you can do real quick to just come up with the right answer, I say go for it. What if it's on a graph? What if there's 2 points? Okay, you're going to have this distance formula, and you're like, ooh, subtracting x's and then squaring them and adding them, that's a whole lot. Really, it's just the Pythagorean Theorem. And again, you're like, well, how's that work? 'Cause I remember the Pythagorean Theorem. That's kind of short. So how's this work? Well, let's try drawing this and see how this works. So -1, -3, and 2, 2. Watch what happens. If I take straight lines to connect the dots, oh, it kind of looks like a triangle. I'm trying to figure out how far it is from here to here, but I know how long this is. It's 1, 2, 3, 4, 5 in length. And this one is 1, 2, 3. Or did I miscount? Nope, I'm right. In length. And I'm trying to find x. Well, the Pythagorean Theorem says that a squared plus b squared equals c squared. And for some of you, that's going to be a whole lot easier to work with, or at least it's going to make this make sense. And again, square root and squared are arch enemies. And if you get a radical like this, just leave it in radical form, because that's typically what your answers are going to end up looking like. Okay? If it comes out nice, great. And again, distance between the other points, it would be the exact same idea. Anytime you have 2 points, I'll do it with the actual formula this time though, so you can see how that works on one of these. Again, you've got your x1 and y1, x2 and y2. Order doesn't matter quite as much as in these as it did the others. And again, notice, just like I did with slope, I'm putting in all my symbols first. So then when I go, I'm like, all right, so 5 and 2 and -3 and -5, and I see the double negative right away and fix it. And you're like, oh, 5 minus 2 would be 3 squared. Keep the parentheses until you actually multiply it out. -3 plus 5 is 2. And you're looking at me and you're going, Harty, what did you just do? Hang on a moment here, because even sometimes you'll see, even I can make a silly error somewhere. So let's see where it is. Here's one of those moments where you kind of have to laugh at yourself. I thought I was doing the exact same problem, just one with using the distance formula and one using the Pythagorean theorem, but I'm doing a different problem. So of course I'm going to get a different answer. If you can't laugh at yourself and kind of have fun with it, what can you do? 1 page to go. All right, we're heading down the home stretch. One more thing with distance here before we move on to midpoint. What's the horizontal distance between these 2 points? Be careful. You're like, why is it be careful? It looks like the rest of them, except for one big difference. Horizontal distance. I don't want the complete distance from one point to the other. I just want to know how far we're running side to side. Now, let's think about that for a minute. Horizontal. Which axis goes horizontally? Well, that's going to be x. So all I'm going to be doing in this case is looking at the x values. So the real question here is, how far is it from 3 to 7? You're like, really? That's all you're asking me? Yeah, 4. I'm done. If you want to be a stickler and use the formula, x minus x. Get the same answer. One word of advice just for future reference. If the word vertical gets used in here, you're only going to use the y values, so you have to read carefully. Okay? Make sure that it doesn't say, if it's distance, we use the formula of Pythagorean theorem. If it says horizontal, just the x's. Vertical, just the y's. Okay, last topic here, midpoint. Add up our values, divide by 2. And again, I'm going to put the parentheses around there because we want to make sure we add, in this case, before we divide. So, on a number line, what's the midpoint between -2 and 10? Okay, -2 plus 10 divided by 2. Work it out, get my answer. Again, if you're more of a visual person, here's -2. Here's 10. In this case, what I would do is I would start at the ends for each, and I would start working my way towards the middle until my fingers came together, and I still end up with 4. Okay? Visual, formula, doesn't matter. Right answer for everybody. Again, be careful with reading though. On a number line, the midpoint between 5 and another value is 1. The midpoint is -1. Okay, picture people. The midpoint is -1. One of the values is 5. 1, 2. So to get from -1 to 5, I went 1, 2, 3, 4, 5, 6 places. Guess what? I have to go 6 places the other way, and I find my answer. Oops, I moved my whole sheet. You're like, well, do I have to do it that way? What if I'm a formula person? Okay. When you're looking for a midpoint, the midpoint is -1. One of my values is 5. I don't know what the other value is. And we just make it a simple algebra problem. And we minus the 5, and we get the same answer. So again, visually, formula, doesn't matter, get to the right answer. Okay. Regular midpoint, again, I'm going to assume you can add up 2 things and divide by 2 to get those. It's going to be 16. That's going to cause us some issues. So one more go here. Again, this is my midpoint. Just similar to 14. They tell us one of the endpoints and they tell us the midpoint. Now drawing pictures on these, I could draw pictures for each of these if I wanted to, but I just want to show you algebraically what I would do if I wasn't going to draw a picture. So for my midpoint, for my x values, okay, and I'm just going to kind of keep using these. So I go, okay, midpoint's at 1. My x value is at 4. Then I'm going to move down a little bit. For the other part of my midpoint, I'm going to do the same thing with my y's. Midpoint's still at 1. My y value is at 3. And then I'm just going to solve those. So I multiply both sides by 2, subtract my 4. Noticing right away, only one of the answers has a -2, so I'm pretty sure that's the answer, but I'll make sure. Multiply by 2, subtract the 3. Looks like my answer, and I'm off and running. Good luck with this. There's a lot, but I know you can do it.